From above, a molten fireball erupting into the sky, consuming thousands of square feet.
Every year, there are over 1 million fires around the world. Together, they claim more than 3,000 lives and injure thousands more annually. But the people most at risk here aren't just everyday civilians. Firefighters constantly put their lives at risk in these situations. In fact, approximately 60 to 70 firefighters lose their lives on the job every year. To prevent these deaths, our team has proposed a solution. Introducing the Firefighting robot. This robot is capable of detecting and extinguishing fires all autonomously.
But wait, let's start from the beginning. This is where it all began. As we walk in, you can see the workspace where we developed our first prototype. Prototype 1 is a manually controlled robot with the FlySky DS16X controller, synced with motors that control the wheels, and a switch that controls the extinguisher. In order to test the efficiency and accuracy of Prototype 1, we set up a testing scenario as shown. There are candles and obstacles set around the floor, and the robot maneuvers around the cups to reach the target points and extinguish the flames. Here are the parts we can use to make a fully autonomous version of the robot, Prototype 2.
To integrate all these parts, we start off with the water tank on the first level, the battery pack, the water motor, the LiDAR, the flame sensor, and the thermal camera all go on the second level, and to pull it all together, the Raspberry Pi on the third level. In order to show a proof of concept of how this prototype will work, we're going to work with a 3D model of our own robotics building here. Imagine that the building catches on fire. We're now going to navigate to the atrium of the building. As you can see, in the atrium, we have about 3 main points of fire. The robot will be sending out a signal through the LiDAR and thermal camera to create a map that it can use to calculate the most optimal pathway to take in order to extinguish these fires. The map will help the robot to sense and locate the closest fire. When the robot gets close enough, the flame sensor will return true, which activates the extinguisher to turn on and get rid of the fire. The robot will then proceed to navigate to the next closest fire and take care of that. The LiDAR and our navigation algorithm run simultaneously so that the robot can always be on the most optimal path. As we went over before, the robot continues to do this until it senses no more fires. The robot will now send out another signal, and when no hotspots are located, the algorithm seizes and the robot knows that the job is done.